let's quickly talk about the structural support of the gastrointestinal organs. As you probably remember, we have several serous membranes in the body, one of which is the peritoneal membrane. And the peritoneal membrane, like other serous membranes, is a double-layered membrane that consists of two sheets folded back on one another with a fluid in between. And so I've used this Ziploc bag as an example. And we can think of one layer being the outer layer and the other layer that will contact the organ being the inner layer. And then we have this fluid which allows the two sides of the membrane to slide over one another and reducing friction. So if this were an organ, for example, our serous membrane would wrap around it and we would have our visceral layer, which is in contact with the organ, and then we would have the parietal layer, which would be on the outside, and we would have the space between filled with the peritoneal fluid, which makes these two layers very easy to slide over one another, and that would make it easy for the organ to be able to move around within this without generating a lot of friction or being caught up on other organs. So you remember that we have a special name for the inner surface of the layers. They are called mesothelium. So the inner sides of this would be composed of a simple squamous epithelium, and the simple squamous epithelium is what's lining the inside of this thing where we would have our serous fluid, and we call this a mesothelium. And surrounding each of the mesothelium layers, which is on the inside of this thing, we have areolar connective tissue. And as we say, if we place the whole thing over the organ, the inner layer that's contacting the organ is the visceral layer, and the outer layer is the parietal layer. And the space between, or potential space between, is the peritoneal cavity or peritoneal space. And really the only thing that's in that space is this very thin film of watery fluid that has some proteins in it to make it nice and slick. And that allows for these two layers of this membrane to slide over one another, and it reduces friction. The other thing is sometimes we will see that when organs that are within the peritoneal cavity, we call them intraperitoneal, when the peritoneum folds back around on either side of the organ like this, then we get a double sheet of peritoneum, and this is called a mesentery. And we will see that there are several mesenteries within the body, and we will talk about them in just a little bit. But first we had to understand the structure of the peritoneum and the fact that we have some organs that are intraperitoneal. That means they are within the peritoneum. The peritoneum surrounds them. And other organs that are called retroperitoneal. So that if I were the back body wall and this were a retroperitoneal organ, it would be like this. And the anterior surface of the organ would be in contact with the parietal peritoneum because it's not actually in the peritoneum, but it's outside it and it's locked to the back body wall by the peritoneum. So we'll see that there are several organs that are located retroperitoneally. We will see that the major portions of the digestive organs, such as the stomach and most of the small intestine, as well as portions of the large intestine, are intraperitoneal, and other organs within the digestive system are retroperitoneal, such as the pancreas, the first part of the duodenum, the ascending and descending colon are retroperitoneal, the rectum is retroperitoneal, and we actually have a cool little mnemonic that will help us remember what the retroperitoneal organs are, and I'll post that one up in just a bit because it includes not just the digestive organs but also other organs such as the kidneys, the adrenal glands, the superior and inferior vena cava and the aorta, as well as the esophagus, the part of the esophagus which is part of the digestive system that's close to the stomach. These are all retroperitoneal. And if they're not covered in the peritoneum, some of these organs are going to be adventitial. That means they will be surrounded by adventitia, which is a connective tissue layer that helps lock it in to the surrounding organs in that space. So this is the standard medical school acronym for how to remember the retroperitoneal organs, and they spell SADPUCKER. So SAD pucker stands for suprarenal, which are the adrenal glands, the aorta and inferior vena cava, the duodenum, which is the first part of the small intestine, the pancreas, the urinary bladder and ureters, the colon, both the ascending and descending portions, the kidney, the esophagus, and the rectum. All right, so peritoneal fluid, as we know, is produced by the serous lining, and what it does is it provides the lubrication. So it allows for sliding around, as you can imagine, as organs are doing their thing. They will create friction. So they have this lining that allows the two layers of the membrane to slide easily across one another and for the organs to be able to slide over one another. Now, typically, we would make about 7 liters of the serous fluid a day, but very little of that remains within the peritoneal cavity. As we see, just like in the real serous cavity, you would see very, very little fluid inside. As I say, I've put soapy water in here just so you can see it, and it creates a very, very thin film in there that reduces friction. Now, if you were to have too much accumulation of this peritoneal fluid, then this is called ascites, and this will cause abdominal swelling, and this is not a good thing. All right, so we have, as we said before, we have these mesenteries, and the mesenteries are the double sheets of peritoneal membrane that if you have an intraperitoneal organ, the mesenteries will form when the two layers of the peritoneum meet on the other side of the organ. So this is going to connect the parietal peritoneum with the visceral peritoneum, and there is space in between which allows for things like blood vessels and lymphatics to go through. So all these this sort of space between is going to allow for important structures like blood vessels and so forth to be able to get to these areas. This also, mesenteries are very important because they will help suspend the organ and stabilize the position of the organ. This is important because in intestines, when you look at the small intestine, you know there's long and thin and curves around quite a bit. And if it didn't have these mesenteries sort of holding it, then it might start to get twisted in on itself. And you've probably heard of something called colicking, which is sort of a colloquial term, and it happens to horses quite often enough that they have to go to the veterinarian and have something done about it. It happens less often in humans, but that is where the intestine will be twisted to the point that the lumen is closed and nothing can pass through it. And this can be deadly for horses. It can be really bad for humans too, obviously, but it has to be corrected. Usually one goes to the doctor if one feels that some really tension in the abdominal cavity, but also it's fairly easy. Veterinarians have to deal with this all the time with horses. So if the surface of the, or I should say the lumen of the intestine gets twisted to the point that it gets closed, then there can be all kinds of problems like that. There's a blockage, and then nothing can get through, and then the intestines will be entangled up, and that's a very bad situation. So the mesenteries help prevent that. So we've got several mesenteries. One, we have on what we call the lesser curvature of the stomach, and the lesser omentum will connect the stomach with, it's on the superior surface, and it's going to connect the stomach with the liver, and it's going to provide an access route for blood vessels and other structures that'll be entering or leaving the liver. And it's got a little bit of fat in it. So when you look at it, it's got a little bit of fat in it, and it fits right within that lesser curvature of the stomach, which when you look at the stomach is kind of a J-shaped object, and the lesser curve is sort of the interior curve. Then we have a greater curvature, which is the outer curvature of the stomach, which we'll look at a little bit later, and that will have another structure on it that's called the greater omentum. We'll look at that in just a little bit. We have one other fold of mesentery called the falciform ligament, and that's going to help stabilize the liver to the anterior body wall. All right, so here is what we would have if we took out all the non-retroperitoneal organs. We have the retroperitoneal organs left. Here we have the pancreas, we have the adrenal glands, we have the kidneys here, we've got part of the rectum here, we have got the ascending colon and the descending colon over here. These are going to be behind the peritoneum. You see the space, the track that they would run in, and you can imagine that the peritoneum, the parietal part of the peritoneum, will actually be facing their surface. And they're locked into the back body wall. You can imagine the esophagus, which is shown cut here. That is also retroperitoneal. Here we have the inferior vena cava here, and we have part of the aorta being shown here. So these are retroperitoneal. All right, so the greater omentum, as we've talked about a little bit earlier, I jumped the gun on the slide, but the greater omentum basically is going to extend inferiorly and from this inferior lateral surface of the stomach, and it's going to create this kind of apron that covers the small intestines, and it sort of interdigitates between the folds of the small intestine, and it's called the fatty apron. Some people call it the fatty apron. Some people in my previous labs have done it the cheese skirt, because it kind of looks like that. And that's going to hang over the lateral and inferior, from the lateral and inferior borders of the stomach over the small intestines. All right, then we're going to see some adipose in the greater omentum. And a lot of times if people start to accumulate a lot of adipose in there, it contributes to the beer gut. So the beer gut basically is what you get when you get too much accumulation of fat in the greater omentum. And the greater omentum isn't entirely all bad if it's, as long as it's not too much fat in there. It is a padding for the surface of the abdomen. It protects the organs. It also provides some insulation. And of course, there are lipids in there, so it has some energy reserves in them. All right, the mesentery proper. This is that thick sheet. It's double layer serous membrane, double layer peritoneum that has folded around the small intestine, the tube of the small intestine, and doubled back on itself and created this sheet that when you open it up, you can see some blood vessels and lymphatics running through it. And so this is going to be very important for keeping the small intestine from kind of getting entangled up on itself. All right, then we have the mesocolon. And the mesocolon is going to support the part of the large intestine that is not retroperitoneal. So we have the transverse colon, which goes across the top of the abdominal cavity, and then we have that sigmoid colon, that S-shaped colon that is communicating between the descending colon and the rectum. So the sigmoid colon is also suspended in its own mesentery, and we have a name for each of these. The transverse colon is suspended in the transverse mesocolon, and then the sigmoid mesocolon supports the sigmoid colon. All right, so here's sort of a picture. Here we have our greater omentum. It's cut. Here's our lesser omentum. This is the lesser curvature of the stomach. This is the greater curvature of the stomach. Here you can see some little bits of fat contained within the greater omentum. Here we would have the transverse mesocolon holding up the transverse colon, and then we would have the the sigmoid colon would be supported in the sigmoid mesocolon, which really isn't shown here. And then we'll have our mesentery proper, which, as we have seen, is basically this sheet that when you pull out pull apart the small intestine and sort of spread it out, you can see the sheet, and you can see that it provides a very nice route for blood vessels and lymphatics.